This is episode 35 of our Chinmaya Algebra series, and for this video, we are given that x minus y all over z plus y plus z all over x plus z minus x all over y is equal to 1, provided that x is not equal to y plus z. We are looking for the value of z in terms of x and y. So a common or a good first step for this one is to multiply both sides by the LCD, which is x, y, z. So if we multiply this thing here by x, y, z, the first one would be xy times x minus y plus yz times y plus z plus xz times z minus x is equal to x, y, and z. And now we can combine like terms here, and specifically since we're solving for z, we might as well group terms with z. And before we do that, because z here is not isolated yet, we have here z, then multiplied in the group containing another z. We might want to distribute first the coefficients with or involving z. We do that by expanding these terms here. We maintain the first term as it is, and then for the second one, we get y squared z plus yz squared plus xz squared minus x squared z is equal to xy z. As I've mentioned, we will group terms with z squared, so this one and this one will be grouped. We get z squared times x plus y, and then for the z, we get y squared minus x squared. We'll leave this xyz here because although it has a z, I want to group this instead with this one because it has an xy. So we might get something good out of it if we group them instead. So if we do that, if we group them, we get xy times x minus y. This xyz, if we put on the left side, will be negative z is equal to 0. So we have here the steps. And then we have here y squared minus x squared, and here we have x plus y. Recall that we can write y squared minus z squared as y minus x times y plus x using the difference of squares formula. Therefore, from this term here, we can factor out the x plus y or y plus x. So if we do that, we factor out the x plus y. Actually, looking back, this has a z here as well, and this has a z squared here. So we can factor out the z as well. So we have here z times x plus y times the first one would be z, while the second one would be y minus x. And then we keep the xy times x minus y minus z here is equal to 0. Note that we have here z plus y minus x, while we have x minus y minus z here. But we can write this one, the second one, as the negative of xy times z plus y minus x. So this first term here will be as it is, and then the second one would be the factored expression equals 0. And from here, we have a common factor that is z plus y minus x. So if we factor that out, we get z plus y minus x times z times x plus y minus xy is equal to 0. We are given that x is not equal to y plus z. Therefore, this term here cannot be 0. Which means by the zero property, we have here, or we have this expression to be equal to 0. Therefore, we have z times x plus y minus xy equals 0. All that's left is to solve for z. So z is equal to xy all over x plus y. Therefore, the value we're looking for is this thing here. We just write it here, and this is equal to xy over x plus y, and that's our final answer. I hope you learned something from this video, and if you haven't subscribed yet, please consider doing so to help grow the channel. Thank you very much, and see you on the next one. Bye-bye.